So quantum gates, and so quantum gates. Let's see. I think that's probably one of those interesting ones within the guide, because I think it drops um, some important intuition facts that we can use to build upon our knowledge on quantum computing. So basically, it's explaining us. So the simplest quantum gates are the X, Y, and Z. So you basically, it tells us, how, like, what effects do they have on qubits, right? So this is an important piece of intuition. So if you apply an X on a zero, it becomes a one. If you apply an X on a one, it becomes a zero. So it behaves like a classical knot. That's what it's saying here. And then the Z gate does a similar thing, but on the states plus and minus. So this is another important piece of information here. So basically, I think I'm not going to spend a lot of time on this, but you should probably go through those matrices here, because they give you a bit of intuition in terms of what are the effects of those gates on your qubits. So, and then you have kind of the important one here is basically what do the Hadamard and the S do, right? So you have it here in the box. And if you remember what the plus state was the same like this, right? So like this, exactly. So it basically turns zero into that, and it turns a one into the version with a minus here in the middle, and then vice versa. So those are things that intuitively are good that you have in your mind. Exactly. I mean, whether you know really how the Hadamard operator looks like or not, maybe it's helpful, maybe it's not. I don't know. Then you've got the S operation and the S transpose, which have here a similar effect. And so basically, at the end of the day, right? At the end of the day, what this guide is telling you is the operators help you move qubits around that block sphere that we've seen in the other video, right? So it's just a matter of how this is done. And kind of that complicates a bit the current intuition model that I have in my mind, because it makes it a little bit more precise and dirty. So it kind of blurs the intuition, so to say. You've got T gates, and then kind of that's the generic gate. This gate is also introduced in the Hello Quantum command line game, and basically it's a generic way in which you can implement any rotation within that sphere, the block sphere, exactly. And then you've got multi qubit gates, so the control knots, and that's it basically. So long story short, you've got basically a bunch of gates that you know apply rotations or changes in your state, and at an intuition level, you maybe have to uh, get just the gist of what each gate does, more or less. And you can think of the danger of thinking in terms of the block sphere is that it becomes tricky when you have more qubits in the game. And when you deal with entanglement and stuff like that. But those are the basics. It's not that's a fairly I have to admit that's a fairly condensed way of explaining it. So I think here they did a good job, actually.